Okay, and we're back. Looks like the script finished up and copied all the results back to our folder. Let's check that real quick. So we've got our HMS runs as well as our RAS-1D results, runs 1 through 20. So it's always going to give you delete confirmation here. It's going to let you get a chance to say no. This is not deleting this project folder. This is talking about your deploy targets. So in this case, let's just look real quick and see how big that is. 65 gigabytes. Yeah. Now we are ready to run our 2D model. So let's get started. First things first, we don't need any of this. It's all done. Close. We can actually open that. 641. Just to show that all this is in HEC-RAS, it shows up in RAS-Mapper. The first time you open RAS-Mapper, you usually have to go through and find all those results. But here we are. All the plan files are there. All the results files are there. It's just like you ran it in one place. So let's move on. Go into 641. Go into our 2D template. Open this up real quick just to show you what we're dealing with. One thing that you can't do with RAS-Commander for 2D is to do infiltration parameters without any DSS files. I just haven't got that incorporated yet. As of right now, it's kind of an appendage to the build from DSS option. None of our models have 2D all the way at the head end. We've either got low detail HMS 1D, or other boundary conditions. We don't end up having any 2D that go all the way up to the headwaters without any DSS inputs. So we just didn't run into that. If somebody else ran into that, they need this adapted for their use, please reach out. So, all right, where are we? So this is just showing our 2D model. It's showing we do have boundary condition inputs all around the model. Those are all DSS files that are from our 1D model. So that's all we're replacing. We also have infiltration parameters that we need to address as well. So one of the ways that we prepare these geometries for RAS-Commander is to make sure that we have, under our infiltration, we need to have at least one calibration region. So do we have one? No, we don't. So let's create one. This is completely arbitrary, and I'll show you why. We're not actually going to be changing the values of polygon 1. We're going to be changing the base override. So very simply, to get RAS-Commander to do all of our 1D inputs with the same exact run parameters as our infiltration parameters within the model, we're using the exact same run parameters from user run parameters CSV file. And so within here, we define the initial deficit, maximum deficit, etc. This is what we use to create the HMS files and run the 1D model. So this will be used as an input into RAS-Commander for the 2D portion for the infiltration parameters. It's also going to need the infiltration parameters from RAS-Mapper, which this data is exactly what you see here. ID, name, maximum deficit, initial deficit, potential percolation rate. These are populated from your infiltration layer. So as long as your infiltration layer is unscaled, that will work. Otherwise, you'll need to populate it from the data that you use to populate the infiltration layer. But the intention here is to be able to have an unscaled infiltration layer and be able to copy paste directly from that window when you create the calibration region. So now that we've got that set up, let's save our Existing conditions, model. Let's open up RAS-Commander while that is saving. So just like our previous demo, we're in operation mode build from DSS, given our HEC-RAS project folder. We've got one deploy target. Let me enable HEC-03 because I've got it for use right now. We're going to do 4 parallel runs. That's about as many as you can do with 2D at 2 cores. Within here, we are set up for 2 cores per run. We're doing plan 02, same as the 1D. That's your May event. And for our DSS source folder, we're using the RAS-1D as our DSS source folder. And obviously, that's where our 1D output files are located. And the search word is going to be RAS-1D. Our replacement word is going to be RAS-2D. Our DSS file name filter word is still May, because we're still running the May event. That's going to filter everything to make sure that we only return May events. The difference between our 1D and 2D is that here we're using our 2D template. We're doing a 2D output folder, and we're enabling our infiltration overrides. In addition to changing our inputs, because our 1D had all of our infiltration parameters overridden and changed, we're also incorporating those infiltration overrides into the geometry layer by defining an infiltration from RASMapper CSV, which is exactly those infiltration parameters from RASMapper with those column names exactly as provided, and the user calibration run CSV, which is the exact same CSV from HMS-Commander. That way there's consistency. There's also a reduction in any human error that might come across. So it's getting late here, so let's go through this. Same additional settings. There's no difference in the operation of these. It's the exact same script. The only difference is the options that are being defined, as well as the project itself. So let's run all and let's see what happens. Well, we're going to step down through each one of these using our same environment. Get to our GUI. We're not going to change anything. Looks good. Let's get our password in. Okay, so we're copying that 2D template, copying all those 1D DSS files, building our plan data frame, updating all the files, and then for this infiltration layer, we are updating from CSV. So what did we do wrong? No such file or directory. Looks like infiltration from RAS-2D. Oops. Looks like I didn't update my CSV file name. So it's a nice live error. Okay, let's try that again. I had a couple of paths wrong. One thing you do need to be aware of, if you do have extra DSS files, for some reason, here we have we had HMS results. That comes out and has RAS-1D results. For some reason, you'll end up with an extra one in here. All these need to correspond whenever you're using the infiltration parameters option. All of your RAS-1D results should have a run number. See there, I'll undo that real quick. It said RAS-1D, but it didn't have a run number, and so I actually got an error inside of the script because of that. That was from me trying to run the preprocessor before. But just to be aware, the script does depend on you manually reviewing some of your DSS files. If you get errors because there's a mismatch, take a look at your folder, sort by type, make sure that you don't have extra results in there. So let's restart. Let's do this again. From infiltration overrides, I want to execute the above cells. Let's go ahead and run through this. It's going to ask if you want to delete the folder. Yes, this is a folder that we just created. But if you had all your results in there and you'd already run this and you had many, many iterations of results and you just accidentally clicked that button, then you would definitely want to click no. So now if you remember previously in the 1D, as of this point, our project was done. As of this point, we've got all of our 1D results mapped to different plan files and U files, but we also need to override our infiltration parameters, and we're going to do that by copying and creating geometries. So it reads the user calibration data, CSV, and it reads the infiltration data, and then it copies the geometry file and updates the data frame with the geometry file extension and matches the geometry number up for each new DSS file. And then it reads and parses the name of the DSS file, pulls out the run number, and corresponds that with the CSV file, and then overrides your parameters accordingly. So, just to provide a little more context, it actually pulls out over here at the end all the parameters that's going to change. So this is run number 10. These are the parameters that it pulled from the CSV file. And then this is the data frame for each one of the geometries. So this is GO2. This is going to be whichever run that is. You have to look at the table to figure it out. But it scales the percolation rate. So let's go look that up real quick. So if this is GO2, GO2 is going to be run 10. Again. Have this set up for a higher resolution. 1.0, 0.7, and 0.5. So that initial deficit being 0.7, percolation rate being 0.5. So if we were to go back up, this is our original infiltration. We start looking, we got a 0.57 there, 4.11, 2.87, 0.285. Those are scaled. So this gets written back into that same location. So let's open up and verify that. As of right now, we've done our infiltration overrides. We should be able to see it so that we can trust that the script is doing what we expect it to do. And it's actually this copy of the files that gets deployed. So when you open up this folder, your actual output folder, you should be very clear which, what was what and be able to be verifiable, because it made the change and now you can verify it and then you can run it as a separate step if you like. Or you can, once you trust that it's doing what you think it's doing, or you trust the fact that you can verify it afterwards, that you can let it run. So we're going to let this run through all the geometries. The first time you open HEC-RAS, after inserting this to many geometries, this RAS mapper is going to need to go through a process of importing those geometries and reading them. So we're going to let that happen and we'll be right back. Okay, welcome back. Looks like we've got RAS mapper open. Let's get into the geometries. Looking at run 10. Let's get into that infiltration layer. That's our calibration region. We can see it. Oops. Let's get into the actual parameter values. You can see here that our percolation rate and our initial deficit was changed. And that's our base values. So those are our base overrides. If we were to go in here and edit the layer, you can see that we've got base overrides. Of course, it has to be run 10, huh? Is that the right one? No. It's like a little different. So these are so just to explain this, really need to redo the example. Our infiltration data is already scaled. And so it's not going to be quite the same. So let's go. That's 357 and 0.27. 287 and 285 is where I should be for GO2, which is run 10. So let's go check that. It's because putting the 10s first. You can really only check one. So let's look at 10. 2.87, 2.85, 2.87, 2.85. There we go. That's 684, 684, 1049, 287, 285. It's a little tough to verify. Sort order is a little different sometimes. But there we go. So we can verify that that's correct. We can stop editing. No, we don't need to save anything. Nothing changed. And so that's it. I think that shows that everything is correct within that 2D model. We've got each 1D, each infiltration parameter all linked, synced to a run number, to the same CSV file. So we didn't change that CSV file. And so now we can deploy, and we can create the batch files, and we can run. And so we're going to start that here, and then we'll come back tomorrow after this runs overnight, and hopefully gives us some results. So with that, I'm signing off. Okay, we are back after some time. It's the next morning. All the models finished running. We'll just run through these very quickly. I did jump in and just failed a couple of these, closed them, and I do believe at some point the script, I may have closed VSCode. I was working on other things, and so the script does finish in the background with whatever code cell you were running if you don't restart the Jupyter notebook. but it did finish without necessarily getting all those updates back to the terminal. So let's just review these real quick. Out on our local location, we've got DSS files. We got 13, 19, and 5 that got run on this particular folder on this machine. Let's go over to HEC-3, where we were running our other runs. Same thing. So I think I closed one of these. We'll find out here in just a second, because what we're going to do is we're going to run the last cell in that notebook. Let's see if it's not gonna run because it's on a different notebook. So if you do run into this, the way to handle it is to run the user inputs, additional settings. Make sure to populate your paths. Do your import settings, populate your paths. And then you should be able to run your results post-processing. Because then it's got all the paths and everything it needs to be able to do that post-processing. It's probably a little better way to do that, but well, that's why I'm making a video. These are very rough scripts. They do what they're intended to do, but you know, they could be a little more user-friendly, a little more streamlined. This is definitely not a product. This is, if anything, close to a minimum viable product. But it's not a product, so let's see. It's action will delete all files, folders, and subfolders within the deploy target. So before we get done, let's just explain what's happening here. Inside of our demo, we've got all of our 2D multi-parameter calibration files that were just copied over. So let's run these. So that's got all of our RAS-1D input files and all of our RAS-2D. So let's look and see which ones we're missing. Looks like 8 and 9 are missing. So this will delete all folders and subfolders in the deploy target. So yeah, let's go ahead and proceed. That's fine. That's going to clean up all these folders so that you don't have to concern yourself with the fact that it does create a lot of folders. And one thing to note, you know, you don't want to set that temporary folder, try to get cute and put that on a you know, a network file server that does backups. You will regret it, because it will blow your backups up by making copies and copies and copies on copies, running files and then copying them all back and deleting them. It's gonna generate lots and lots of bad data for any, you know, but enterprise level systems that have the type of backup that they typically do with imaging, etc. It's just not appropriate for those. So try to keep it on these local machines. You want this to be temp folders. This is written, changed, and deleted, and you want that to remain in that paradigm. So now we've got everything back, except for those 2 runs. So let's clear all outputs real quickly. Let me open up. I did start this example in 6.5, and I did realize that for whatever reason this model doesn't run in 6.5. It runs well in 6.4.1, so we went back and made sure to do that. Let's open this project. It's on my working folder, demo, multi-parameter calibration, and we're going to let this load up. So if it's the first time that you've opened RASMapper since creating that folder, it will go through a process of reading each geometry file and putting those in the RASMap file. I haven't figured a way around that, but it is nice that it does it automatically. It just takes a minute to run through them all. You do want this on your local machine for that reason. So we're going to pause the recording here and let this finish and come back. Okay, we're back. We've got RASMapper open. It took a second to open. Let's go in here. Got our infiltration calibration regions. Let's open that attribute table. Oh, sorry, not attribute table. And there we go. there's your unscaled infiltration parameter values. I did have to fix that. That was wrong a little while ago. It was scaled to what our actual optimal values were at this stage of the calibration, but not the original unscaled values. So here we've got the original unscaled values versus the actual scaled values for run 10. So yeah, just show all those are different. So then all of these different results, we're not going to pull all these results. It takes a long time to pull profile lines out of this many sets of results, but all of the results conditions are right down here, or all the results layers are right down here. And we'll go through in another video how to automate the extraction of those results straight from the PDF file for specific gauge locations. That's pretty straightforward analysis. We've got DSS-Commander to do that for the 1D portion. And so, yeah, got all of our different results, and we're not going to poke through all these results. The intention is just to show that we're able to automate the parallel running and the results collection, and these are now able to be open in RAS or processed externally if you've got an external solution. So with that, hope you enjoyed this video. We'll be including another video for DSS-Commander. We'll take an example of some of our 1D results. We don't have any gauged areas for West Fork within the 1D, so we'll take from our Whiskey Chitta model where we have a 1D model and gauged flows within that 1D area. We'll use DSS-Commander to present, compile our comparisons and provide report-ready visualizations as well as calibration metrics.